preparing. Now, I think we are live now. Let's see what Evangelos in the background.
Oh, I can see the live icon. Okay, this is very exciting. Fantastic. So, good evening, everybody. Welcome to the second podcast of Astronomy on Tap Jena. We have a fantastic event for you today, and you're going to hear a lot of background noises, but that's normal. Okay, so let me stop sharing if I can.
Wait. We are not live yet, says Evangelos.
We're not live yet. Oh,
no,
okay.
so let's wait for a moment. Maybe there is this delay. Maybe it's a little bit longer.
It's a little bit longer than 20
Yeah.
seconds. Okay.
So just
I'll
wait.
Not a problem.
I will see if I can find it on YouTube, so that we can share the link.
Yes, and if you cannot find the link, just go on our YouTube channel and it will be there showing live.
Yeah.
Fantastic.
Okay.
I think we should be visible now to people, no?
Yeah, I can see myself.
That's very important. Okay.
Yeah, okay, good. All right.
Fantastic. We can see ourselves. That's very important. So good afternoon again. There is a very big delay between Zoom and YouTube, and we were worried that we wouldn't get you guys or you wouldn't see us. So welcome to the second event of Astronomy on Tap Jena. We have a lot of games. We have 2 interviews with 2 fantastic scientists who will share their experience and expertise with us. And we will have a lot of fun. We have a fun quiz for you. So let me stop sharing so you can see our beautiful, beautiful faces in the background. So I am Eleni Vardoulaki. I'm a researcher at the
Thuringian State Observatory.
I will say it right. Thüringer Landessternwarte Tautenburg. It was not easy for me. And I'm a coordinator of data intensive radio astronomy. And I do a lot of outreach also. And we have Fabienne with us.
Hi. I'm Fabienne. I'm a master's student right now. And I'm writing my master's thesis about atmospheres of exoplanets at the Thuringian State Observatory in Tautenburg.
And we have 2 guests today. Thank you very much for joining us. I know everyone is busy, so we really appreciate having you with us, and we are very looking forward to tonight. Let me introduce you to our audience. So our first guest is Dr. Susanne Hoffmann. She started her career at the Public Observatory and Planetarium in Berlin, while also achieving a double degree in physics and science history. Her love for astronomy influenced her voluntary commitment to spreading astronomical knowledge internationally. For example, Siberia. Okay, so we'll tell us more about that. This engagement also brought her to the area of teaching methodology. Today, her interdisciplinary research focuses on cultural astronomy and celestial phenomena. And now she is at the University of Jena. So good evening, Suzanne. Welcome. And our second guest is Dr. Emilio Romano-Diaz. He was born and raised in Mexico. He got interested in physics and astronomy at an early age that finally led him to do a PhD at the Kapteyn Astronomical Institute in Groningen in the Netherlands. He then moved to Israel, to the USA, and now is in Germany at the Argelander-Institut for Astronomy in Bonn. And he holds a research position. His main interests are cycling, triathlon, and of course, how galaxies form and evolve in the universe. He makes extensive use of some of the most powerful supercomputers in Europe and the world in order to understand how, for example, our galaxy formed and acquired its shape. So he also uses 4 different types of bicycles. Okay, that sounds very exciting. In order to keep his mind sane and in place from all the signs. Okay, welcome, Emilio. Thank you for being with us. Thank you, guys. Fantastic background, both of you. Suzanne, you take us to the stars, and Emilio takes us to the University of Bonn in the background. So let's welcome also our audience, right?
Yeah. Hi, guys. I hope you can see us now in your live. And I have 2 questions for you. So it would be nice if you could type it in the chat. And Evangelos, our guy in the background, is then texting us what your answers are. So question 1 is, where are you at the moment?
Let's welcome also our audience.
Oh, yeah. Where are you at the moment? So which city? Probably you're spread all over the world. We hope so. And the second question is, what is your relation to astronomy? So if you would say, I have no clue of astronomy, it just happened like that I'm now online on this YouTube stream, then type a 0. If you say, oh, I'm interested in astronomy, but I don't know too much, then type 1 for beginner. If you are a student in physics or astronomy, type 2. And if you're an expert, an astronomer, then please type 3. So then we know better if we should explain difficult words or things in astronomy during our live stream. Yes, thank you.
Okay, good. It will take us a bit to get responses. I really don't like this delay. No. But you know, we have to wait for good things to happen. We can wait. We can raise our glass.
Yeah.
Cheers.
Cheers.
Cheers. Thank you again for being with us, and hopefully, in the very near future, we can do this in a pub and enjoy each other's company, not in the virtual world.
Yeah, I hope this too. Hopefully next year.
Yes, and we have some very nice pubs and places here in Jena that I'm really looking forward to exploring, because I moved here quite recently and I wasn't given the opportunity to explore these fantastic places.
I think I showed you a few bars, like the Krenowski and Theater Cafe.
Yes, Theater Cafe was very nice. So, okay, while we wait, shall we start the game?
Yes, let's start the game.
And then the audience can respond at their own time. Yes. So this is what I will do. I will copy the questions for the audience in our chat, and you guys can respond whenever you want. Okay, it's already done.
Okay,
and now we will go to the first game for our speakers, just to break the ice a bit. So it's called Taboo. Those who know Taboo, you know the rules. We will give one word to one of our guests and 4 words that they cannot use to describe it. And our other guest needs to describe it, to find what is the word. So let me start with Emilio. Just a second. Emilio, this is your word. It's in the chat.
Chat?
Yes, yes. Don't say it loud, just describe.
Yeah. But have we explained the rules? Sorry.
Do it again.
Okay, so for example, you have to explain the word cloud to Suzanne, but you're not allowed to use 4 words that we texted you in the chat. So in this case, sky, haze, water, or atmosphere. And it might be a little bit difficult, but it's doable. And I will take the time or stop the time. I would say for the beginning, we say 30 seconds.
Yeah, that sounds good.
Okay, stop sharing again. Okay, so Emilio, are you ready?
Yes.
Okay, so go.
Yeah, okay. So it was common in the paintings of the Middle Age that people actually will have something in top of their heads, particularly saints.
Nimbus?
No. So they had it in the form of a ring that it was in the top of their heads. How was that called?
A crown?
Again?
No. We also have them around the Milky Way.
Halo?
Yeah.
Yes.
Time is over. Okay.
Very good, very good.
I thought the way was still allowed to say it, not galaxy.
You almost said galaxy. That was good. I didn't. When I thought of this word, I didn't see the connection with the angel. So
because they also have the halo.
Yeah, fantastic. Very
yes,
good.
but I did know only the Latin word. So sorry.
What is the Latin word?
Nimbus.
Nimbus.
Nimbus. Okay.
Then it came to my mind like cloud. No.
Yes.
Going that way.
Okay. So now we have the second word for Suzanne. I'm sharing it privately in the chat. So the word you have to describe is in quotes, and you cannot say the next four.
Okay. Are you ready, Susanne?
I think so.
Okay, then let's start.
So this is a state of objects like the sun. Objects like the sun, how are they called?
Stars? Plasma?
Objects like the sun. Those are?
Objects like the sun? Like star.
Yeah. So we have got stars, yes, and stars, big stars, at the ends of their lives, and white dwarfs.
Red giant.
Time is over. I'm sorry.
Oh,
really? That's fast.
Maybe we can give a bit more time.
Okay. Go.
So white dwarfs and big stars.
Red giants.
And
supernova.
Yes.
Very good. So
very good.
It took 55 seconds, but not too bad.
Okay, that was not easy because we didn't. It was very difficult with all the restrictions we made.
Yeah.
You could not say star, you could not say explosion or evolution, which is how you would describe supernova, like evolution of the star, right? How a star evolves. Right. So congratulations to both. Let's go to the next one. This is for Emilio.
And let's say you have now also 54 seconds, to be fair.
So the first word is the one you have to describe, and the four after are the forbidden ones. Not easy.
Tell me when you are ready.
I'm thinking.
That's it. It's a good start.
Yeah. Okay.
Okay. So go.
So it's a part in science actually where you want to test if your theory actually matches results.
Simulation?
Yes.
Wow.
20 seconds. Wow. Amazing.
Very good.
You're a great teacher, so you're really good in explaining, so we could all learn from you.
Very good, very good. So that was impressive because I had forbidden words, model, supercomputer, algorithm, observations. It was very difficult. Well done. Okay, so the last one. That's
I like the last one.
Well, the last one.
You're crazy.
No.
Sometimes.
Okay, tell me when you're ready.
Mhm.
Was that a
Yes.
yes? Okay, good. Then go.
It's a constellation. It's in the northern hemisphere. There are several constellations of this type, describing an apparatus to measure.
Big Dipper?
An apparatus, a machine, and not really a machine.
Yeah. A machine?
Well, a tool with which you can measure positions of stars.
Yeah. The sextant.
Yes.
Okay, 30 seconds.
Good.
Very good.
Very good.
I couldn't even remember the name of the apparatus. Like, oh my God.
Yeah, I was
That was hard because we had words eye, angle, horizon, and instrument that Suzanne could not.
and great idea to explain it with the constellation.
Well, they are two, octant and sextant, and the octant is in the southern hemisphere.
Fantastic. So now that we broke the ice, I hope you guys enjoyed that. Let's see if our audience has greetings from Hamburg. Well, hello to you too. Oh, and hi from Greece.
Yeah.
Hello. Hello. Kalispera. So, good. Let's go to the next part. So I leave it to you. I will mute, and Emilio mutes, and we'll leave it to you and Suzanne to discuss in German.
Yes. And it's always so difficult to switch to German if you've been speaking English the whole day.
Imagine if you don't speak it.
Ja. Okay, also auf Deutsch, nochmal von mir auf Deutsch, hallo. Und Susanne, sehr schön, dass du heute mit dabei bist. Entschuldigung, dass Sie heute mit dabei sind. Englisch, Deutsch, ja, das ist die Schwierigkeit.
Das ist nicht schlimm. Also wir können auch zum Du wechseln.
Okay, gut, also Susanne, du hast ziemlich viel gemacht in deinem Leben, was mit Astronomie zu tun hat. Also wirklich sehr, sehr beeindruckend. Und vielleicht fangen wir da an, ja, wo für dich die Karriere in der Astronomie gestartet hat. Und zwar hast du in der öffentlichen Sternwarte und Planetarium in Berlin angefangen, und zwar eine Ausbildung. Wie kamst du dazu?
Ja, das schreibe ich immer so, weil es damals, also normalerweise in den öffentlichen Sternwarten ist es ja so ganz oft, also Urania, Jena oder so, dass man da einfach hingeht, sagt, hallo, ich bin XY und ich möchte jetzt was über Astronomie erzählen, weil es mir Spaß macht. Und das ging halt damals in Berlin nicht, sondern man hatte damals im Ostberlin der 70er Jahre eingeführt, dass da ein Wissenschaftler den Thron besetzt, also den Abteilungsleiter bzw. Direktor. Und der war, als ich da angekommen bin, war dieser Wissenschaftler-Häuptling tatsächlich zum Professor geworden, war gleichzeitig Professor an der TU Berlin. Und der hatte eben die Maßregel, dass jeder, der dort in der Öffentlichkeit über Astronomie Auskunft gibt, also die Kassiererin durfte das einfach nicht, sondern der musste dort sozusagen eine hausinterne ein Prüfungssystem durchlaufen haben.
Okay, ja.
Und man konnte hinkommen und sagen, ich mache jetzt einfach alle Prüfungen, aber also das habe ich effektiv so gemacht. Ich wusste schon vorher ganz viel, hatte mir autodidaktisch viel beigebracht und wurde deswegen dafür ja quasi auch angesprochen, das zu machen. Aber einfach so ging das trotzdem nicht, sondern man musste im Laufe eines Prozesses sich dazu qualifizieren. Also man musste halt zum Beispiel Umgang mit Teleskopen zeigen, und dann musste man effektiv das machen, was heute Bachelorstudenten machen. Also ich sag mal, die Ausbildung, die wir damals absolvieren mussten, von jedem oder von mehreren bestimmten Typen von Beobachtungen etwas durchführen, eine Sonnenbeobachtung machen, eine Jupiterbeobachtung machen und ein 3-Monats-Projekt und so. Das ist effektiv das, was an der Uni Jena gerade Astropraktikum plus Bachelorarbeit ist.
Ja, ich kann mich noch erinnern. Übrigens, Susanne war meine Betreuerin im Astropraktikum. Wie alt waren Sie damals, als Sie diese Ausbildung begonnen haben?
Naja, ich kam so mit 15, 16 dahin, habe gesagt, ich würde gern hier arbeiten, also um Astronom zu werden. Und so kurz nach meinem 18. Geburtstag war ich dann damit fertig, habe ich die Abschlussprüfung beim Professor gemacht.
Und warum genau Astronomie? Also was hat Sie daran fasziniert?
Tja, das ist eine ganz lange Geschichte.
Okay.
Also ganz viele Sachen. Ich könnte jetzt sagen, ich war mit 7, 8 Jahren war ich dauernd im Planetarium, weil das gerade neu eröffnet wurde, und dann liefen da tolle Vorträge über Sterne und Galaxien und so weiter. Ich bin am Stadtrand aufgewachsen, da wo es noch wirklich dunkel ist hinterm Haus, und ich war immer fasziniert und wollte mehr darüber wissen. Und manche wollen das einfach.
Ja, nee, geht mir ja genauso, aber ich dachte, vielleicht gibt es einen anderen Grund, ich weiß es nicht. Okay, interessant. Und dann dachten Sie, ich switche jetzt die ganze Zeit von du zu sie, aber es ist, glaube ich, okay. Und dann dachten Sie, okay, das will ich jetzt mit einem Studium weiterführen?
Genau, also eigentlich, als ich so 9 oder 10 Jahre alt war, da wurde ich dauernd gefragt, was ich mal später werden möchte. Und ich bin aus einer Medizinerfamilie, darum habe ich damals immer sehr entschieden gesagt, ich will irgendwas studieren, aber nicht Medizin.
Okay, rebellisch.
Ich wusste irgendwie sozusagen das Akademische, so, das ist schon meine Veranlagung. Ich möchte einfach wissen, was dahinter steckt. Ich will immer wissen, wo es herkommt und wie es funktioniert und so. Ich wusste nur überhaupt nicht, was das Wort dafür ist. Und also das Wort Physik habe ich erst viel später gelernt. Das heißt tatsächlich auch über die Astronomie, weil ich mich für Astronomie interessiert habe. Dann wollte ich wissen, wie wird man Astronom? Und dann hat man mir gesagt, ich müsse Physik studieren. Das war auch damals so. Heute würde ich das so rigoros nicht unterschreiben. Aber also man kann auch Informatik studieren oder Mathematik. Aber grundsätzlich so von der Idee her war es das dann. Und ich habe tatsächlich sogar schon so circa mit 13 gesagt, naja, Wissenschaftsgeschichte ist tatsächlich auch sehr interessant, denn es ist ja, das zeigt, wo es herkommt.
Okay.
Also ich will immer wissen, wo es herkommt und was dahinter steckt.
Ja, weil das ja auch Hand in Hand geht. Ich meine, die Modelle, die wir entwickeln, hängen ja auch immer stark damit zusammen, wie weit die Gesellschaft gerade entwickelt ist oder welche Weltbilder man hat. Also von daher kann ich das schon verstehen, aber ja.
Es ist so ein bisschen, also ich habe das mal salopp so formuliert gegenüber einer Studentin, im Prinzip sozusagen, ich will das Rezept dafür wissen, wie man Nobelpreise kriegt. Also wie kamen die Leute auf sowas?
Ja.
Wieso haben sie sich das gedacht? Also es ist ja nicht so, dass irgendwie so ein Einstein irgendwie auf seinem Sofa oder Ohrensessel da vor sich hin lümmelt und dann plötzlich der Geistesblitz von Zeus heruntergeschleudert wird. Es ist ja immer ein Prozess, und diese Leute, wir sind alle Zwerge auf den Schultern von Riesen. Wir haben eine bestimmte Ausbildung, bestimmte Einflüsse von bestimmten Menschen erfahren, die uns in die eine oder andere Richtung prägen. Und das fand ich einfach interessant zu wissen, wie gesagt, wo es herkommt.
Ja, also ich kann jetzt nur aus meiner Erfahrung sprechen. Ich meine, ich studiere immer noch Physik und ich finde das schon ziemlich schwer. Von daher Respekt, dass Sie dann noch nebenbei quasi angefangen haben, Wissenschaftsgeschichte zu studieren. Ist das richtig? Sie haben das quasi parallel gemacht. Also Sie haben erst mit Physik angefangen und dann während Ihres Physikstudiums mit Wissenschaftsgeschichte angefangen und in beiden Fächern promoviert?
Jein, ich habe erstmal beide Fächer studiert. Tatsächlich habe ich zuerst nur Physik studiert, und das lastet einen völlig aus. Noch dazu mit Nebenjob und Familie, um die man sich kümmern muss und so weiter. Aber ich merkte schon, dass Physik zwar spannend ist, und wie gesagt, ich wollte das wissen. Ich habe Physik studiert wirklich auch aus der Leidenschaft heraus, dass ich es wissen wollte. Aber irgendwie merkte ich auch, wenn ich die Welt verstehen will, dann reicht Physik alleine nicht. Und darum habe ich überlegt, was könnte ich noch machen, und tatsächlich auch das Umfeld in der Archenholz-Sternwarte. Da gab es eben ganz viele Leute, die sich mit historischen Fragen beschäftigt haben, mit Wissenschaftsgeschichte auf eine sehr spezielle Weise, aber sie haben das getan. Und das gab dem Ganzen dann wahrscheinlich noch so den letzten Kick. Noch dazu, also dass ich dann auch wirklich gesagt habe, ja, ich möchte das wirklich studieren. Noch dazu war das so, dass ich Physik in Potsdam studiert habe und meine jüngere Schwester hatte inzwischen, also während ich mein Studium begonnen hatte und brav meine Physik gemacht habe, da hat dann angefangen, 2 Jahre später meine Schwester zu studieren. Und zwar wollte sie gar nicht sowas in die Richtung machen, sowas Kompliziertes, sondern nur ein Studium irgendwie absolvieren, um der Welt zu beweisen, dass sie es kann. Und
so
was sie interessiert hatte, das ist überhaupt nicht abwertend gemeint, ja? Was sie interessiert hatte, war eben unter anderem Geschichte, also viele Nebenfächer bei den Magisterstudiengängen damals, aber jedenfalls hat sie mich dann hin und wieder so ein bisschen angestupst. Die FU Berlin-Dahlem ist ja nicht weit weg von Potsdam, da fährt man mit der Bahn eine halbe Stunde. Und dann sagte sie mir so, ich habe da und das Seminar, Vorlesung, irgendwas, komm doch mal mit dazu, die Dozentin oder der Dozent erzählt ja irgendwie manchmal was über Astronomie, dann kannst du mir das hinterher erklären. Und das war natürlich historische Astronomie. Also wenn es irgendein zum Beispiel Seminar über die alten Ägypter war, dann wurde da hin und wieder mal was über deren Astralkult oder so gesagt. Und ja, dabei war das auch so ein bisschen so eine Wechselwirkung, Synergie mit meiner Schwester, die dann sagte, komm doch mal mit.
Ja, schön. Und Sie haben sich in Ihrer Forschung viel mit historischer Astronomie dann auch beschäftigt. Also was genau haben Sie da vielleicht gemacht? Vielleicht können Sie uns ein bisschen was erklären, weil ich finde es sehr interessant. Und vielleicht können Sie auch sagen, warum das oder warum die Forschung in vergangener Astronomie noch sehr relevant ist für die heutige Forschung.
Also meine Diplomarbeit, ich habe eine Diplomarbeit geschrieben in Wissenschaftsgeschichte. Das habe ich über die Technikgeschichte von Fernrohren gemacht, und zwar im 20. Jahrhundert. Wir wissen alle, oder zumindest 3 von uns, dass in Tautenburg heute dieser große 2-Meter-Spiegel steht. Und wie kam es eigentlich dazu? Was steckt dahinter? Und das ist eigentlich nur ein Nebenprodukt meiner Diplomarbeit, aber also das Thema, das Kernthema, um das ich dann alles drumherum gebaut habe, war eben die Erfindung der Medialfernrohre. Das sind Hybrid-Spiegel- und Linsenteleskope. Das ist eine Ingenieursidee gewesen, 1899, und das wurde dann im 20. Jahrhundert mehrfach gebaut und getestet. Und das hat mich interessiert. Und wie gesagt, für Tautenburg, als es noch in der Planung war, wurde darüber mal kurz gesprochen, ob man da sowas macht, hat sich dann aber dagegen entschieden. Dieser Fernrohrtyp, der wurde quasi dann von der Raumfahrtgeschichte überholt. Also sozusagen, es wurde ein Riesending gebaut, ein Riesenteleskop, steht in Brandenburg, aber es ist dann nicht weiter nicht in der Sternenforschung eingesetzt worden, höchstens in der Sonnenforschung, sondern man hat sich dann mehr auf die Spiegelteleskope konzentriert, und dann kamen auch ganz neue Technologien, bevor diese Hybride sich so richtig ausgebreitet hatten. Das ist einerseits, also so der technikhistorische Aspekt, also warum jetzt diese bestimmte Technik heute nicht genutzt wird, ist ja nicht so alt, das ist eine brillante Idee. Also ein farbfehlerfreies Linsenfernrohr zum Beispiel. Das hat mich einfach auch quasi technisch interessiert. Und meine Doktorarbeit habe ich gemacht über Astrometrie. Und da ging es im Wesentlichen um die griechisch-babylonische Astrometrie in der Antike, also Sternkarten, Himmelsgloben. War Hipparch wirklich derjenige, der die Magnituden erfunden hat? In Klammern vielleicht, aber wir wissen es nicht.
Ja, es ist sehr schwer, mit dem Auge die Helligkeit eines Sterns zu bestimmen.
Genau, also das haben die sicher in der Antike gemacht, denn der Katalog von Ptolemäus überliefert das ja, aber es steht in jedem Grundlagenbuch der Astrophysik drin, dass Hipparch das erfunden hätte. Und ehrlich gesagt, wir können ihm das nicht nachweisen.
Okay.
Aber es geht nicht darum, wer hat wirklich was gemacht, sondern was ich eben spannend fand, war sozusagen wirklich die Astrometrie. Wie genau konnten sie messen? Womit haben sie überhaupt gemessen? Und auch der Kulturtransfer hat Ptolemäus wirklich alles selber beobachtet oder Hipparch, oder haben die vielleicht babylonische, ägyptische Daten oder Daten von anderen Griechen vor ihnen? Woher kommt das alles? Und da hat sich auch nicht damals jemand hingesetzt und sich gedacht, oh, heute mache ich mal ein Koordinatensystem.
Ja.
Also erfinde ich jetzt mal. Was Ptolemäus gemacht hat, war, dass die Kugelkoordinaten von Länge- und Breitenkreisen, die am Himmel definiert waren, auf die Erde zu übertragen. Aber für den Himmel hat er sie auch nicht erfunden, sondern er hat sie zwar vielleicht zum ersten Mal so nebeneinander hingeschrieben, aber das hatte Vorgänger und wie gesagt,
Festgehalten, ja.
genau, also so wie kam es zu dieser Entwicklung und warum hat sich dieses System durchgesetzt und nicht ein anderes und solche Sachen.
Da schließt sich gleich die Frage an, was denken Sie denn, also Ihrer Meinung nach, welche Kultur, historisch gesehen, hat denn am meisten zur Astronomie beigetragen? Oder war vielleicht für Ihre Zeit sehr, sehr weit entwickelt?
Naja, das kommt wirklich immer sehr drauf an. Jetzt muss ich zu meiner Schande gestehen, ich weiß sehr wenig, also wirklich nur Oberflächliches über die lateinamerikanischen Kulturen. Also Maya und Inka hatten auch eine sehr hochentwickelte Astronomie. Über die Aborigines in Australien wissen wir nicht viel, weil das alles nur mündlich, also wir haben keine Schriftdokumente. Das heißt, was dort an möglicherweise hochentwickelten Praktiken und Kulturen existiert hat, das entweder wissen wir nicht und haben auch keine Chance rauszufinden, oder es ist gerade auch noch dabei, erforscht zu werden von anderen Leuten als mir. Es ist tatsächlich so, dass im 2. und 1. Jahrtausend die Babylonier so richtig vorgeprescht sind. Die hatten ein riesen Tagebuchprojekt, also das sind nicht wirklich Tagebücher, sondern eher Monatsbücher, wo aber monatlich festgehalten wurde, was genau wann wo passiert ist. Also wo Saturn gerade stand, wo Jupiter stand, wie hoch der Pegel des Euphrat war und viele andere Dinge, womit man ja eine Datenbasis geschaffen hat, die ermöglicht festzustellen, ob jetzt wirklich, was weiß ich, der Pegel des Euphrat mit dem Aufgang von Sirius zusammenhängt oder sowas. Wenn man diese Datenbasis nicht hat, dann kann man nur spekulieren und Esoterik oder Religion betreiben. Aber man braucht die Daten. Und das haben die gemacht. Also irgendwann im 7., 6. Jahrhundert fängt es an, dass wir erste Zeugnisse davon haben. Wahrscheinlich zu der Zeit haben sie es angefangen. Das ist sensationell. Und sie haben auch schon, wir können auch schon sehr hochentwickelte Mathematik der Babylonier nachweisen bis ungefähr 2000 vor Christus. Wow. Also so 1800, 1900 vor Christus haben wir quasi Mathematik-Schulaufgaben überliefert, die zwar nicht dezidiert astronomische Anwendungen haben, aber die eben dann sozusagen das Sprungbrett sind für die Astronomieentwicklung im 2. Jahrtausend vor Christus.
Ja, das ist sehr beeindruckend.
Es ist möglich, dass die Ägypter sowas auch hatten, aber das wissen wir nicht, weil das nicht textlich überliefert ist. Es ist möglich, dass die Chinesen das auch hatten, wissen wir nicht, weil es nicht textlich überliefert ist. Die Griechen zu dem Zeitpunkt noch nicht. Dafür haben die später einen unglaublichen Clou gelandet, weil die Griechen dann die Babylonier haben alles nur phänomenologisch beschrieben. Denen ging es nur darum zu bestimmen, wo steht Jupiter übermorgen oder nächstes Jahr. Und warum der da steht, ist denen völlig egal. Sie wollten einfach nur den Algorithmus finden, um es rein phänomenologisch zu rechnen.
Ob sich das wiederholt und wann sich das wiederholt. Ja.
Genau.
Ja, vielleicht auch von Relevanz. Also ich meine, allein schon Jahreszeiten zu verstehen oder zu wissen, wann eine Flut kommt, ist ja auch relevant für eine Kultur.
Definitiv. Ja. Und dass sowas wie zum Beispiel Jahreszeiten die Schneeschmelze steuern und damit den Pegel von bestimmten Flüssen, ist uns heute klar, aber das musste man ja erstmal rausfinden.
Ja.
Und wie gesagt, die Griechen haben dann den nächsten großen Clou gelandet, indem sie gesagt haben, wir wollen jetzt wissen, warum das so ist. Wir wollen zunächst mal mechanistische, aber dann später rein abstrakt mathematische Modelle schaffen, spielt eigentlich keine Rolle, ob es wirklich so ist, ob da wirklich ein Zahnradgetriebe ist, das die Sphären antreibt. Aber wir machen uns ein Modell und damit können wir es besser vorhersagen. Weil wenn diese Zahnräder das schaffen, dass der Jupiter aus der Sphäre darüber zieht, dann kann ich es auch quasi mit meinem Uhrwerkgetriebe vorhersagen oder mit reiner Mathematik oder so. Und das gibt einem nochmal ein weiteres Handwerkszeug. Und das war aber zu einer Zeit, als das babylonische Tagebuchprojekt dann quasi schon fast am Aussterben war. Also das ging so ein bisschen ineinander über. Und deswegen kann man das, glaube ich, nicht so pauschal sagen, sondern man kann schon, ich finde es immer falsch zu sagen, so die einen haben das gemacht und dann später haben die anderen das und das gemacht. Also
es baut ja auch aufeinander auf. Ja.
Es baut aufeinander auf, es greift ineinander und das ist ja auch so, dass, also was wahrscheinlich auch einen chinesischen und indischen Kulturtransfer in der Zeit gegeben hat und so.
Ja, ich finde nur, dass wir also heutzutage halt mit einem sehr westlichen Modell von Sternzeichen und so weiter arbeiten und Also ich fand es einfach mal interessant zu wissen oder überhaupt auch über andere Kulturen zu erfahren. Also es war mir einfach gar nicht bewusst, dass es auch einfach andere Sternbildersysteme gibt oder einfach eine andere Herangehensweise. Und ich finde das echt super spannend. Ich würde auch noch gerne viel, viel mehr mit Ihnen drüber reden. Aber vielleicht noch kurz eine ganz andere Frage. Und zwar, Sie haben sich schon früh ehrenamtlich eingesetzt, um astronomisches Wissen in die Welt zu tragen. Und Sie waren auch in Sibirien auf einer Exkursion. Und was können Sie über die Bildungsverhältnisse dort sagen? Und
Die sind
wo
super.
genau waren Sie da überhaupt?
Also es begann mit der Sonnenfinsternis 2008 in Zentralsibirien. Also da gab es ein riesengroßes Projekt des deutsch-russischen Jugendaustausches, an dem ich die Astronomie quasi geleitet habe, also die Astronomiegruppe dieses Projekts. Und ich war auch von Anfang an der Organisation beteiligt. Ich habe es nicht selber organisiert, das hat die Stiftung DRJA gemacht, also Stiftung Deutsch-Russischer Jugendaustausch. Das ist also auch ein politisches Ziel inzwischen, seit, glaube ich, 2005 gibt es diese Stiftung oder 2006, in Deutschland den Jugendaustausch mit Russland zu fördern. Und auf diesen Zug sind wir quasi aufgesprungen als Astronomen und haben gesagt, dann nutzen wir das. Wir machen 2008, veranstaltet die Astronomie eine Sonnenfinsternis und zwar diesmal in Sibirien. Und da war es tatsächlich so, dass wir in Novosibirsk waren, also wirklich mittig in Sibirien. Sibirien ist der asiatische Teil Russlands, beginnt also ab dem Ural und geht bis quasi zur amerikanischen Grenze. Und ist also quasi die Hälfte von Asien, ist Sibirien. Ja. Und das heißt, das ist ein riesiges, großes Land, das ist Kontinentalklima. Diese Sonnenfinsternis war im Sommer, das ist also zu einer Zeit, wo Sibirien nicht tief im Schnee steckt. Kontinentalklima, das heißt, man hat 30 Grad plus, wärmsten Sonnenschein und wunderschöne Natur, großteils unberührt. Wir sind mit der transsibirischen Eisenbahn dorthin gefahren. Und also wirklich von Berlin, da kamen ganz viele Leute, 150 Leute aus Deutschland kamen nach Berlin und wir sind alle zusammen über Minsk, also Warschau, Minsk, nach Moskau und von da mit der Transsib 2-3 Tage nach Novosibirsk gefahren. Und dann hatten wir da ein schönes Projekt. Und das war aber eben auch als Initialzündung gemeint, um, wie gesagt, den Austausch allgemein anzustoßen. Und ich habe dann ganz viele Projekte organisiert mit Leuten, also Austausche und Spacecamps und so mit Leuten aus Novosibirsk und Iskitim, das ist ein bisschen südlich davon, eine etwas kleinere, weniger berühmte Stadt. Novosibirsk selber hat eine Elite-Universität, also das ist sowas wie deutscher Exzellenzcluster, denn im Zweiten Weltkrieg waren ja die großen Städte, gerade in Europa, Moskau und St. Petersburg und so mit den berühmten großen Universitäten, die waren natürlich im Kriegsgefecht. Und man hat alle kostbaren Hirne des Landes dahin gekarrt, wo garantiert kein Deutscher hinkommt. Also kein deutscher Hitlersoldat, meine ich. Also hat die sozusagen in Sicherheit gebracht und hat in Novosibirsk eine Elite-Universität mit ganz exzellenter wissenschaftlicher Ausstattung hingebaut.
Wow.
Ich habe auch dann also das ist bis heute auch noch immer super gut ausgestattet, ist bis heute eine der Exzellenzuniversitäten sozusagen Russlands. Das Bildungssystem ist super, weil das sehr auf Konkurrenz, also auf Wettbewerb ausgerichtet ist. Da geht nicht einfach jeder in die Uni, weil er gerade Lust dazu hat oder von den Eltern dahin geprügelt wird, sondern weil man durch ein Prüfungssystem, das man durchlaufen hat, sich qualifiziert hat und sich sozusagen auch quasi berufen fühlt dorthin. Und dann habe ich auch Projekte gemacht mit Krasnojarsk und Omsk. Das sind Nachbarstädte, das heißt, man fährt mit der Transit einen halben Tag. Ist also so weit wie weiter als von Kiel bis nach München, aber es ist halt so, dass das Nachbarstädte sind. Dazwischen ist nichts. Oder ein paar Milchkannen. Ja. Ich habe übrigens auch, also das mit den Projekten, diesem Ehrenamtlichen, das war ganz viel mit Russland. Ich war aber nicht nur in Russland, sondern ich war damit auch in zum Beispiel den USA 2017 zur Sonnenfinsternis. Und ich war auch allerdings nicht ehrenamtlich, sondern um dort Geld zu verdienen in Afrika, in Mauretanien und habe dort Astronomie.
Ja, Sie waren, glaube ich, an ziemlich vielen Orten. Also ich weiß, dass Sie auch in Österreich waren. Ich glaube, da haben Sie ein Planetarium geleitet.
Ja, und der Sternwart.
Ja, Also sehr, sehr beeindruckend. Und ich glaube, wir könnten jetzt noch Stunden reden. Wirklich. Sie haben so viele interessante Sachen gemacht. Aber ja, ich muss auch ein bisschen an unsere Hörer denken und würde jetzt vielleicht noch mal kurz eine Frage stellen, die uns alle ja, einschließt. Und vielleicht noch mal kurz an der Stelle, falls ihr, also unsere ZuhörerInnen, Fragen an Susanne habt, dann könnt ihr die gerne in den Chat schreiben und wir werden versuchen, diese zu beantworten. And now I switch to English again. So, Eleni, Emilio, hi. Maybe I want to put this question for discussion and not just ask Susanne. So my impression is that astrology, not astronomy, but astrology and esoteric is very big at the moment. So people in my age, it's a new trend. And people are making so much money out of it. And I thought, why am I not making money out of it? I mean, I'm almost an astronomer, but no, of course, that would be wrong. So that's my opinion, because you, I don't know. I mean, you could say it's a religion and you can believe in it, but somehow it doesn't feel right, because you say, I don't know, Venus or Jupiter and Saturn are soon in conjunction. So the energies are now perfect, I don't know, to build a new family or whatever. And I don't like it. So what is your opinion? Should we as astronomers do, yeah, I don't know, should we do something against it? Or have you ever thought about making money out of it?
Second question is a clear no. When I started at the observatory in Berlin in the 1990s, we had a director who spent his life on fighting against astrology. Mm-hmm. And me personally, I don't think that this is correct, because you cannot convince somebody to not believe in his or her religion.
Yeah.
That is why, of course, I can argue. And if somebody asks, I can present all the arguments of the world, but I cannot decide for the person whether or not he or she believes.
That's
so
true.
I can tell the history, and that is what I always did in planetariums and planetarium presentations and museum guiding tours and whatever I did, public talks and so on. I always said that this is a history. The Babylonians invented the zodiac as coordinate system, and the Babylonians invented this sort of divination because this was their religion and it fitted in their worldview. In the meantime, there were 2,500 or 3,000 years of science, and we have a new worldview now. I don't believe anymore in the Babylonian religion. So why should I believe in astrology? But well, this is only my personal opinion, and I can tell the people I cannot convince them because it's their belief. So I gave up. I totally gave up to convince anybody.
Okay, I get that point, but I think it's difficult to make money out of it if you convince other people to believe in astrology and then take their money.
Well, yes, I totally agree that I cannot make money of astrology.
Okay.
I'm personally not able to do that. I'm personally also not able to make money out of selling stars.
Emilio, what do you think?
Well, I think it's not that simple and it's complicated. I think that what we can do as astronomers really is educate people on actually what it means, these constellations, no? That they are just a representation in the sky and they don't have really any power over us. No? Mm-hmm. But I mean, Suzanne was talking about the Babylonians, but it's been reflected in many, many cultures along the history of humanity, you know? And I think that it's really ingrained into our society, Western society, and not only Western society, almost in the whole world, in humanity. And that's why it's so difficult to believe that. No, so people go to pyramids to get the energy from the sun or from the moon, from solstice, from equinox. No, you see that in Stonehenge, you see that in Mexico in the pyramids, or other places, and it is always in there. No, so the idea to believe that the stars or planets actually play a role in us kind of make us feel like we are not only responsible, we are not completely responsible for what is happening to us, but like there is an entity behind all these that make us feel probably more comfortable. No? Mm-hmm. So I think that what we really need to do is really educate more and more of what it means, the constellation, what it means, all these astronomical phenomena that, well, no, I mean, unless there is a nearby supernova, they won't have any effect on us.
Yeah, that's the point. There is no physical power. Yeah. Okay. Thank you for your opinion. Eleni, what do you think?
Making money out of astrology. Very tempting. Given that you can never make money out of astronomy. But in the past, there were astronomers, and this is how in the 1600s, no? 1500s. I think Suzanne will know more about these things since you're in astronomical history. That in order to attract funding from the kings and the wealthy, they were making their horoscopes. Yeah. So actually astronomers of the past were also astrologers in order to survive and get funding. Now we get funding from funding bodies. So we actually have to write scientific proposals and convince a panel of scientists that it's worth to give us money to do our science, and we don't gain money through astrology.
But I believe that
we should change. It's not only your generation, it's from the moment someone is born, it's the influence of their environment, it's the culture they get born within. They tell you, you are a Pisces, you are a Scorpio, this is your personality, this is how you are. So eventually you start believing that this is what you are. It's a very powerful
thing.
From 0 day, this is you, this is your character, this is what you do, you get aggressive, blah, 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 whatever the horoscopes say. I agree with Emilio, it's a way to find comfort in your life, and also to know what the future brings, because we don't like uncertainty as human beings. We like to know what's going to happen to us, and also we don't like responsibilities. We like to blame someone. So having a culture around astrology and horoscopes is a good way of doing that.
And it might also explain your life situation. So if you have a horrible time and then you think, it's because of the stars, okay, then maybe you can live with it. Yeah.
I totally agree. The only way to not go to eliminate it is not possible, because in some cultures it's part of the culture, like in India, for example. But the only way is to educate people, and this is what we're trying to do. So through public outreach and taking the scientists out of the lab, out of their office, and talking to people, to schools, to the young ages, and to every age, we would try to educate people. And
I think we have also the responsibility to do that, because I think we should share our knowledge, as you, Suzanne. So
that's what we do here, and this is what scientists should do anyway. We should not stay in an office and just do science for science. It's one way of giving back to...
Yes, and well, I think it's a privilege that we are paid by the state. I mean, the state gets tax, and these taxes are used to pay scientists. And well, to be honest, there are only few people that you can catch with a public talk on the differential equations or something like that. So that is why, I mean, astronomy has this beauty and this romantic aspects and all those wonderful questions of how does the universe evolve, and how do we go, where do we go, and where do we come from, and so on. And this is what all human beings want to know. And it's like the IAU says, it's the one sky for mankind. We are all under one sky, and it's a question or a topic of hope, the stars. And that is why, I mean, the starry night sky or something like that. And that is why I think it's our duty as astronomers to go to the public on behalf of all the other scientists.
I like that idea very much, and I agree.
So something that it is worth mentioning that here in Germany, the different funding agencies, not like the DGA, the DFG, sorry, etc. Like now, when they grant you money for doing research for the next 2-3 years, independently if it's for you or for paying students or postdocs, is that now they try to make you more participative into spreading the knowledge via all this with the community, you know, or through SFB. So now they are developing chapters within these research collaborations between different universities, in where certain part of the time or the money that actually is being given for the research should also be spent in terms of popularization of science, particularly what they do. And I think that that is very positive. Still, there is a long way to go. I mean, you know very well, we not all are capable of expressing or trying to explain really what we do. It's not easy. We not all have the same skills to do that, but I think that we are getting there, no? And the hope is that I hope really that with time we will get better and better. Not only a few people, no, but most of us actually should be able to share that knowledge.
Yeah, that's true. Okay, I would end this discussion here. Thank you for your thoughts. And okay, I would hand over to you, Eleni.
Okay, we have another game, no? Right? Yes.
Yeah, true.
We have a game. Okay, now it's more fun time. Now that we got a bit depressed with astrology winning all the fun, we're gonna educate you a bit more with true or false. So get ready, Suzanne and Emilio, because you have to guess if it's true or false. So we have a set of questions, and I'm starting.
Wait, if you think it's true, then just thumb up. If you think it's false, thumb down, and you can think, I don't know, a few seconds about it. You don't have to answer immediately.
Okay, so the first one, Titan, Saturn's moon, is yellow. True or false?
Sorry?
Titan, Saturn's moon, okay, is yellow. Is this true or false? Is it yellow?
It's always difficult to answer questions on color.
Yes, of
course. I mean, I know the color, but is it yellow? I don't know.
Okay, conventional.
Okay.
Okay, very good. You are correct. It looks yellow also in the pictures. This is what we call a true color. It's a mix of methane, green, and carbon monoxide, which is red, and ends up being yellowish. We can share the link with our audience if they want to investigate a bit further, you know, and do some fact checking. Right. So the next one, sorry, I have too many windows here. The next one. It takes 6 days to fly to the moon from the Earth.
Nowadays, I think it's more, no?
Okay, you're correct. It's wrong. It's false. It takes 3 days, around 3 days, to travel from here, the Earth, to the moon.
I mean, of course, it depends on how
you go,
fast you travel. Yeah.
Yeah, I mean, of course.
Of course, it's impossible to go there by bicycle, but
you never know. Maybe one day, and probably Emilio will own the bicycle.
Yeah.
His fifth bicycle is going to be that one.
It would be 9 years by if you walk. It would be 9 years. So I doubt it would be 3 days by bicycle.
It's going to be a super amazing, super duper bicycle. So the third one, clouds at the center of the Milky Way smell of rum and taste of raspberries.
I
want to say, no! What? No, it's true. It's true. Okay. So ethyl formate, it has a couple of intriguing properties. It is responsible for giving raspberries their flavor and has the smell of rum, and the center of our Milky Way is full of it. And a fun fact, so there is a region close to the center of our galaxy which contains enough alcohol to supply every person on the planet with 300,000 pints of beer per day for the next billion years.
Per day? Whoa.
Sadly, it's a very low percentage of alcohol. It's only 1%. But hey, it's for, the next billion years.
But I think it's actually difficult to smell raspberries and rum in the Milky Way if you can't breathe. So maybe you should catch some of the ethyl formate and then you can smell it.
Right.
Yeah.
So that's a fun fact. Right. The next one. Neptune has only completed one orbit around the Sun since we discovered it. They cannot see. Neptune has gone only once around the Sun since its discovery by us. Yes, sorry, I was not looking. Yes, it's true. Okay, so Neptune takes 165 years to complete one full orbit around the Sun. And it was discovered in 1846, and it only recently finished the first full circle, so in 2011. Right.
It was discovered in Berlin, by the way.
It what?
It was discovered in Berlin.
Really? Fantastic. Fun fact. Great. So the last one. Okay. How many did you find? You found all of them apart from one? Yes. Good. Astronomers estimate that there could be more than 200 billion rogue planets floating free and drifting through our galaxy.
Maybe an explanation.
I don't know exactly the number, but I believe it.
No, the specific no.
Maybe for our audience, usually planets are bound in a solar system like ours. So a star in the center and the planet is moving around it. But there are also free-floating planets. And so this says that astronomers estimate that there are more than 200 billion of these free-floating planets in our galaxy. Suzanne, you said no?
The statement is that theoretically they think that there's this number.
Yes, theoretically.
Yes, probably yes, yeah.
Well, I think it's very hard to estimate, right? Something like that, of course. But how do you get a rogue planet?
Collisions in the formation of the same three-body interactions. Yeah, I guess.
So it can be kicked out of a solar system, basically due to movements.
Yeah, that you have a binary system, and then you have the planet. So because of the mass difference, these guys will be the first ones to be kicked out. For example, that's one mechanism comes to my mind.
A binary system is two stars. Right?
Yes.
Yeah. Sorry, just for for the ones like me that have no knowledge in astronomy. We did a quiz on the on the chat before when you were talking with Suzanne are about our experience, and I said 0. Good. Well done, guys. You did very well, very, very well. So now we will do a very, very quick interview with Emilio in English, just to keep a bit the ball rolling, sorry. And then we will go to our quiz. So guys in the audience, in around 15 minutes, get ready to play. And we will share the link on the live chat, right? Yes. Okay, so let me get my questions up, Emilio. And have a lot of questions for you today. I'm very, very curious about your career in astrophysics. And how did you choose this career path? You said that you were interested since a child. Do you have any relatives?
Suzanne was saying, the romantic part of the astronomy, I think that it catches our attention or imagination or eye at a very early age. So I was lucky to be born in a really small town where it's not that we had many, but when there were starry nights, there were very impressive starry nights. And you always look at them and you say, oh, what is happening? What is this? Or what are they? I remember asking to my grandmother mostly about the stars and this and that, not until I guess that my grandma didn't know anymore about them. And at the same time, I also, the different phenomenal physical phenomena that you look around, like simple rainbows, the halo around the sun, that you see them, then you ask, why? I mean, why do we see them? What are they made of? So all these questions actually start to trigger my curiosity, and that's what first led me to physics. But I always had the bulk of really doing astronomy, cosmology in particular. So then I start to get more and more in close contact with astronomy. And finally, when there was a moment to decide during the universities, when I say, yes, I think that's my path. Although I actually wanted to do theoretical cosmology at the beginning, I ended up doing something completely different, but I still enjoy very much what I'm doing now, the part of studying why galaxies and how they form.
So you study how galaxies form from what do they form from?
So, so once that you start into astronomy, then you really have to decide what it is. And that's actually something that we have to learn. That in astronomy there are so many different fields that it's also actually difficult to catch up with all of them. You might think as an external that, well, it's just the study of the stars or something like that, but no, it's much. There is much more than that. So at some point, I start to get interested in numerical simulations, and in particular of how the galaxies acquire the shape and the form that they actually have. Like if we see, for example, our own galaxy or a nearby galaxy like Andromeda, is that they are disk systems that they are rotating. They are flat systems. They are not spheres, but they are kind of flatted systems that they are rotating over an axis. And then actually you start asking questions like, why? Why is that? How come they actually came into being this particular way? Then, of course, there are many along the courses you study, like angular momentum, for example, like the certain conservation laws are very important for these systems. And you do some calculations and you are able to do that. But there is a point where you can only do calculations with paper and a pen until a certain moment, and then you realize that it is not enough. So that you have to find a different way to try to explain the dynamical evolution of these systems. And then it's when actually computers come into play, because the equations that describe the motions and the evolution of the galaxies get so complicated that it's not possible anymore to find theoretical solutions. So you can only do something that is called a toy model, like you make a very simple representation of the galaxy and you can evolve it like that. or the systems, and that's how, but until that moment, so once, if you really want to go more into detail, like for example, why galaxies have a bulge, why they have the disk and the different type of disk or spiral arms, then you really need to go to numerical simulations in that way. No? So they are part of the story. Still, theoretical solutions are very, very important because they really give us the insight of what it is. And then the final result, basically nowadays, is given by simulations.
Right. So I have two questions. More. What is the recipe that makes a galaxy, for example? And where does this galaxy live? So the universe that it starts from. What is it's made of, and how?
Galaxies are, as we want to think about them, is like they are. There is a signature in the formation of the galaxy, even from the moment after the Big Bang. After the Big Bang, when we have, when people actually have seen the cosmic microwave background, so we see that there are some maps where there are some hot spots and cold spots, what they are called red and blue, and things like that. And some of these features are the places where galaxies will form. Now, exactly how it happens is that what we believe is that after the Big Bang, there were some very tiny perturbations in the density field of the universe that actually these tiny perturbations grew up by the time of the universe, is also a particular time of the universe. And this actually made gravity, that certain matter concentrated slightly more in particular regions, and then it's just gravity. So it's just a plate of gravity there that comes into play. That as how the universe evolved, these perturbations actually start to concentrate more and more matter. So the matter flows towards these regions, and then these regions start to grow, become denser. So what we believe, actually, it's there is a very pretty picture of a theoretical work developed in the 70s, where actually before we really knew about the existence of dark matter, of other components, dark energy, that it came really to explain the formation of galaxies. No? And it's pretty much, let's say in general terms, accurate until nowadays, that this picture that it was developed in the 70s. So what we have is that the matter really comes into the center, it's accreted, then gas follows, and when there is a certain density in the gas, and the gas is able also to cool, because we need that, I mean, in the universe, so then it starts forming stars. And once that the first stars form, they evolve. So they have winds, they eject material into the interstellar medium, they produce metals, they enrich the medium. And metals are very important because actually they also help to increase or to facilitate the star formation of in other regions, in the gas, because metals actually allow the gas to cool down. And in order for the gas to continue collapsing and form a star, you need it to cool. So you need these metals. And this is a reaction chain. So you start forming stars, they evolve, they throw material into the interstellar medium, more stars start to form, and you start to have a family. At the same time, different stars are formed of different masses, so then you end up with stars that become very massive, and they explode as supernovas, like very powerful events, and they pollute the interstellar medium with many, many metals. Other stars like our sun evolve much more passively in longer periods of time. And at the end, after 13 gigayears of evolution, basically you end up with a system like our own Milky Way. So these are systems that they are called, supported by their own gravity. So that means that all the stars within the galaxy are confined, but then they are formed by gas, dust, sure, planets, and stars. That's mainly the main components of that. And all this system is constant dynamic change. I mean, there are so few galaxies that sure, they seem to be like nothing is happening inside them. There are some others, for example, our Milky Way, like it's still producing stars around between 1 and 5 stars per year. And there are other galaxies that are much more active, producing many more stars. No, so the systems are completely in evolution. And for example, we have a neighbor that is the Milky Way, and the the Andromeda Galaxy to the Milky Way, and we believe that in some million years, in many million years, actually the two galaxies will collide. The two galaxies will collide and will form a different system than what we see today. No?
Yeah. So it's gonna be a different galaxy, probably a different shape, more round, right?
That's actually something that we can learn, for example, from numerical simulations. So in the past, people always thought that the merger of two galaxies like Orion and Andromeda will lead directly to a elliptical galaxy, a more rounded galaxy. But now actually we know that it also depends on the amount of gas that they have in the merger, that each component bring with them. So it can be that at the end of the day, after they merge, they produce a much more massive, but still a disk galaxy. The disk might be destroyed, but it reforms very quickly, depending on the amount of gas that there is, and if the gas is able to cool down. And so, not necessarily, but so for example, this is something really very nice that numerical simulations were able to predict, and actually it has been kind of confirmed with observations. I say kind of because it is difficult to really see. I mean, with observations, we only see one particular picture at a particular time, and we cannot see the whole history. No? Simulations, on the other hand, give us that opportunity that we can see the whole picture evolution of the whole movie of the formation of the galaxy. No?
Yeah, that is amazing. You can see how it starts and how it will end up, right?
Exactly. So this, of course, it depends pretty much if our theories for galaxy formation really are right or not, you know. And at the end of the day, I mean, this is, for example,
amazing.
This is exactly what we want to reproduce, and we want to see, you know, that numerical simulations are able to reproduce the galaxies that we see in the universe. And this is a numerical simulation. This is a galaxy that we made at the University of Bonn in the group of galaxy formation. And we are very happy. Also, we are at the moment where actually our simulations or numerical models can reproduce many properties of the galaxies, although many others not. So our models are far from being realistic, but we are in our way. No, we are in the way to do that. Not only us, I mean the whole community in astronomy. I think that we are getting there.
How so? You have to plug in a lot of information, right? All this, the recipe of a galaxy, what it's made from, and how it starts from these perturbations, like in the early universe, and how it evolves. It's a lot going on inside this algorithm, let's say. So you use supercomputers for that, right? How long does it take to, for example, to produce a galaxy, to evolve it from nothing to a Milky Way?
So it all depends on, so there are different aspects here. No? So it is very important, the amount of physics that you put into your models. And the other is the scales that you are able to reproduce, not that you are able to distinguish from one another. So for example, it is important because gravity actually will make that two objects will get close together. No? But in terms of computing time, the closer they get, the more time needs to do the calculations because objects are moving around each other, and then every time step that the simulation takes, it takes more and more time because more calculations need to be done. So if this is for two objects, imagine when you have around a million objects or 10 to the 11 of a billion objects, billion stars. No? So it becomes very, very time consuming. So for this, we have to do numerical simulations in supercomputers. So we are also very fortunate that here Germany has invested a lot of money in some of the most powerful supercomputers in the world. But in general, Europe, there is this consortium that actually is very interested into supercomputing, not only for astronomy, but for different sciences like biology, chemistry, physics, engineering, where they have built some of the most powerful supercomputers, and you can access to the time. So you have to write a proposal, like going to the telescope, and you have to say why you want to apply, when you want that time for the computer and that. But basically, we are saying that we apply for 1 million hours easily for each object that we want to reproduce. No? So this object, for example, in the background, it took around 1.2 million hours to do from the moment of the Big Bang until now. So it is a lot of time.
It took
us 3 months, slightly less than 3 months to do it, among other things that you have to check that the simulation is running properly. You have
to... so if it's wrong, that's it, eh? I mean, if you start it and it's wrong.
Well, many times you are able to catch when the simulation is wrong, so you develop an instinct of how things should be. Okay. But sometimes you don't catch up the error until the end. And I can tell you by experience with some collaborators that they have spent around 20 million hours, and only until the end they found out that actually the simulation was kind of wrong. Okay. Now, what does it mean really that is wrong or what is right? I cannot tell you actually if the simulation really is right. We say it is right because it's able to reproduce some of the observational properties that we see in galaxies. Not
so
like
you compare with observations, right?
Exactly. But there are many other things that we are not really sure that the simulation is completely right. No? So, or that we are able to reproduce all the properties from the observed galaxies. No? Now, does that mean that the simulation is wrong? Not really. That is completely right? Not really either. No. So we are always there. So of course, the more physics you put is the risk of screwing up things, because then you have to pay attention to many, many more things. No? So it's not only the stars, it's also the gas, the temperature of the gas, for example, the distribution of the gas and dust, if you can do that. No. So what does
you
it
learn,
mean?
Right? Sorry, but you learn even if you plug in something that is not completely right.
Sure.
From our theoretical perspective, you learn from it.
We have tests apart from the intuition, no, and apart from the theoretical knowledge that we have gathered. We have tests that we know that simulations actually should match. No, those results should be in this way, more or less in that other way. But even then, that you have those tests that have been matched properly, it still doesn't mean that the simulations are correct. No,
right?
Sure. I mean, you can reproduce a cubic galaxy. You obviously say, yeah, no, that's completely wrong, right? So that's easy to see, but there are other properties that you don't know until probably later on, and that is the fun part of it. No, it's like you really learn making mistakes, and you learn from them, and that's how you improve. No, what can we do better here? What can how can we code these physical phenomena in a much better way? And this actually leads us to the fact that we not only need people for this, in particular galaxy formation, people that actually work on galaxy evolution, but we also need the knowledge from people that work on the stellar evolution, or that study the stars, that they study the interstellar medium, the different properties of the stellar medium, the people that actually you need from cosmology in order to understand the first parts of the simulation of the evolution of the universe. So I think that's one of the parts that I really like from the field, that it gathers knowledge from all different areas, no? Like in other fields in astronomy. It gathers also this knowledge from all the different areas in order to be able to come with sensitive simulations and results.
Yes, that is fantastic, and it promotes collaboration a lot, international collaboration. So I wanted to ask you, how do you find the situation now that we're going through a pandemic, we are at home, we're forced to work from home, and we have to maintain our international collaborations, and it's a bit challenging, isn't it?
Yes, it is. I mean, at least from for a simulator, you only need a computer,
Okay.
which is the good part. The bad part is that also you only need a computer, no? So,
Yeah.
so in that sense, it kind of makes easier the work, because as long as you have access via internet, that is the other problem. That there were days when the network was down, and they said, well, I cannot really do something, but you always can read papers, etc., etc. But it is challenging in the sense that you cannot travel now. You cannot go to conferences. You cannot go to present your work. That is very important, because a relation, exposing your work also to other people, it helps you a lot to grow and mature your own line of research. You know? So you learn from other ideas. You learn from what people are doing in different places, etc. You know? Now, with all the pandemic, they have come up with also some kind of clever ways to try to continue still with these conferences or that. It is not the same. I still think that it's pretty good, but there's still, I think, is the physical contact and the physical interaction with the people. It's what it makes it interesting. You know? Of course,
yeah.
we are different people and we need to socialize with others. But and while Zoom, well, thanks to Zoom, we are talking now from Bonn and Jena, you know. So it really has helped a lot. It is still not the same, but I think it's at least we have great tools in order to continue with that. No, the other point is
very hopeful. That's very hopeful.
Yeah.
Okay, let me ask you two quick things because we're out of time. And then we will go to the questions from the audience. Evangelos has been sending me some things. So if you had to choose, so these are, you know, personal questions. If you had to choose between a world where you could only do observations or only simulations, which one would you choose?
I think observations.
Okay.
I think observations.
Good answer. Good answer.
Yes, simulations are the tool of simulations is to explain what we observe. No,
Yeah.
Of course we have managed to predict many other things. That is pretty good as well. But it's a simulated world. No? So.
Yes, and okay. Now you have to be very honest. If you had to choose between a world in which you could not do astronomical research and a world in which you could not cycle, which one would you choose?
That is difficult. I personally love the bike because it really gives me the breakout from the science and from the daily life. No. But it also gives you an opportunity to think about sometimes about nonsense or sometimes about nothing really, but some other times really about see the problem in a different way. So
it's hard, eh? I'm sorry. I asked the hard questions. I asked the hard.
Yeah, no, I know because I mean, in order to survive, I need astronomy, and in order to pay for the bike, I need astronomy.
Great.
It's still 50-50 there.
It's difficult. Yeah, I also would not know which one to choose. Cycling is fantastic, although you love it a bit more than me. 4 bikes, amazing.
for different type of terrains.
Oh wow! You would love Jena, I tell you. It's fantastic here for cycling and also mountain biking. So we have questions. First of all, thank you very much for all this information. We have a few questions. First, I will ask if dark matter is included in this kind of simulations.
Yes.
Yes.
They are the backbone of the simulations, basically.
this is where the galaxies lie, right?
Exactly.
Like the skeleton of the universe, the dark matter. And another thing, because you also mentioned dark energy, so dark energy is what makes the universe accelerate fast, go fast and fast and fast, just for our audience. So Jim is asking, what is your favorite science book?
It's one of the first that actually I read as a youngster. I think it's The Pleasure of Finding Things Out from Mr. Feynman, Richard Feynman.
Okay, that's very nice. And also, again from Jim, can we have a bit of advice for a university student who wants to follow astronomy, astrophysics? What shall they do?
I don't know if Suzanne wants to say something about that.
I mean, yeah, maybe Suzanne, you want to jump in here?
Sorry, repeat the question. A physicist student, what?
So a student of physics wants to continue in the astronomy path. How can they follow this career path after studying physics?
I think you cannot, not at all plan this.
Okay.
I mean, you can ask a professor if he or she gives you an opportunity to do the next step, whatever that might be. I mean, bachelor thesis, master thesis, doctoral thesis, but it's not at all sort of schedulable or plannable.
Okay, that's.
Some
people try to schedule it, though. I mean, they do the right.
Yeah, but that's unfortunately that's the mad thing in science, especially in Germany, because you cannot get a permanent position in science, and this is one of the most important reasons why so many brilliant people leave science, at least in Germany. I mean, that's different in France and in the US, for instance, because there they offer the people who are sort of good enough a permanent position aged, say, 30 or 35. But that's not the case in Germany. You can be as good as a Nobel Prize winner, but do not have a permanent position, except you are Didier Queloz and work again for something like that.
Yeah, it's not trivial at all. It's very difficult to get.
I mean,
yeah, in general in the world, there's not enough funding. There's not enough permanent positions, and also the culture of astronomy, where you have to move a lot every few years from place to place, does not support a very healthy lifestyle, and does not support family lifestyle either. So
yes, for many people, yes. But well, if you have the luck and discover something really important when at a young stage, for instance, if you find the first exoplanet while you are doing your PhD thesis or something like that, then you might have a chance that the university will not force you to go away. Otherwise, I mean, in Germany, for instance, currently I'm a postdoc. And if I apply for third-party funding, there are certain rules like do not go back to the place where you did your PhD. So 2 of the universities in Germany are ruled out by default. I mean, they're the best places in the world for me to do my research, or might be, but I cannot go there because this is the rule.
Yeah, that's very frustrating. I understand. Well, any other questions? Thank you, Suzanne.
I think that something apart from reading books, if people really want to go pursue this, is like if they are already not necessarily even in physics, or people, for example, in engineering and this can also go try to do summer schools or try to find some summer schools. So actually, now that there are so many tools on the web, like webinars, like this or something, just give a peek on them. No, just register and listen. Of course, at the beginning you will not understand anything, but challenge your curiosity, and if you think it's for you, well, you can always try to do something temporarily, and see if this is your could be your path or not. Then later on, other decisions in life will affect that. But
that's a very nice advice, actually. Also internships at the younger age. So when you're a student, you can do an internship at a research institute and see if you like it. And then, very, very good idea. Thanks for suggesting that. Okay, Emilio, one last for you, because I don't like to disappoint Jean-Claude. So the question is, I have heard that galaxies were colliding with each other more in the past. Is this true? If so, why? That sounds very sophisticated. Let's see.
Yes. The answer to the question, yes. The collisions between galaxies were more frequent in the past. And that is because the formation scenario that we envision of how the structure in the universe came to be is something that we call from bottom up. So that means that the first structures, like the first stellar groups, clusters of stars, actually form, and then they grow. But growing means that, yes, they acquire gas and then form more stars, but also that they meet other stellar groups, they merge, and that's how they grow. In the same way, so you have here a bigger structure, and another group here of stars actually form, and then they merge. At the same time that you are doing this hierarchical process, you are also emptying all the regions around. So the probability to find another object which you will merge actually decreases with time, just because you don't have it. Unless you are in something that is called clusters of galaxies, where there are many, many galaxies in a very close, small ball. So then encounters there will be more often. But in the rest of the universe, and the filamentary structure of the universe, galaxies will have more and more difficulty trying to find another galaxy of the same size or so in order to merge. And so that's why.
Thank you very much, Emilio. We should move on. Although I really, really like to talk about galaxies, obviously. Okay, so we have the quiz, right, Fabienne? Thank you, Emilio, again. Thank you, Suzanne, also for contributing to this discussion. And let's go to the quiz, and you guys can also play. So we give the link to our private chat, and you can put the code. Guys, we have shared the link on the live chat on YouTube, and click the link and put in the code. You will have to give your name, right? Just simply register. You don't give any information out, don't worry. And, only your private data. Take it on, Fabienne.
Yeah, so this is the website. And thank you, Emilio, again for this interview. Very interesting. And you can type in this code here, and then we can play the quiz together. And I can see here the names, so I know some of you, like Matthias. Hi. Jim, I think you sent us some questions. Thank you for that. Alex, Mukul, of course. Okay, Blah. Hi, Blah. Extraterrestrial. And NGC4414.
Wow.
What is it, radio astronomer?
It should be a galaxy, no?
I don't know.
I will Google it.
Okay, Emilio and Suzanne, can you find the quiz?
It's an active galaxy, spiral galaxy.
Okay.
I had to type in the
I am multitasking.
Έφαγες λίγα. Μάμι, έφαγες λίγα. Γιατί είναι έτσι?
Emilio and Suzanne. Okay, so let's start. The questions are difficult. Oh, good that I waited. Some more players. Okay, but get ready. So there's a countdown. Which lacus or lake is on Titan and not on the moon or at the moon? It's difficult. Okay. I think many people are struggling. Temporis, Varus, Dolores, or Matthias was, Alex, Suzanne, and Emilio. Very good. So how do you pronounce it? I think it's a Greek leg, isn't it, Eleni? Or Greek name?
Which one? Sorry, I can only speak
Trichonida.
Trichonida. It's Greek. Trichonida.
Trichonida.
Yes.
Okay. So good. This was very difficult start. Mm-hmm. Next question. First mission to photograph the far side of the moon, launched in 1959. Luna 3, Luna 6, Luna 9, or Luna 12? To be honest, I wouldn't have known the answer to that question. Okay. Most of the people say it's Luna 3. And of course, you are not allowed to Google. That would be too easy.
Who would have done that?
You mean who set up the questions?
Well, I have another laptop beside, so I can just quickly Google.
Okay, it's Luna 3. Most of you were right. Very good.
Very nice.
Yeah.
No, honestly, I did not.
Okay. Next question. First probe to Mercury launched November 3rd, 1973. So we have New Horizons, Spirit, Opportunity, or Mariner 10. I have no clue of probes, to be honest.
I know all the answers.
Okay. So most
people can bribe me.
Okay. Suzanne, not bad.
Wow, very nice, very nice. So
well, this was the first one I really knew.
Okay.
The next one is Mariner 10.
And Suzanne, you said I'm bad in games. That's not true.
Well, I just have to play with my computer mouse.
Okay, first probe to land on an asteroid. So near Shoemaker, Hayabusa, Giotto, or Rosetta? Okay, most of you say Rosetta.
Tell them.
Okay, I think most of you were wrong. I know Rosetta is very famous, but it was near Shoemaker.
Yeah, it's not the first one.
3 people.
Yeah, Rosetta was on a comet, and Giotto was a Jupiter probe, wasn't it? Oh no, it was in the orbit. It was not a probe.
You see, you know more things than us.
That's why we invited you.
Yes.
Next question. Okay, a neutron star on Earth would weigh 1,000 tons, 100,000 tons, 1 million tons.
Who does put a neutron star on Earth? Who does this?
Just for reference. To weight it, I mean.
I brought it here.
Okay, I can already see most of you are right.
Okay.
Yeah. 1 billion tons.
Yeah. Okay, Suzanne.
I was not fast enough to click this time.
Yeah, but you're still at the first place.
Oh, I see.
Yeah.
Well, I won't answer anymore.
What is the diameter of a neutron star? We had the mass. So is it 15 kilometers, 150 kilometers, 1,000 kilometers, or 15,000? Yeah. So I hope most of you know what a neutron star is. It seems so.
What is a neutron star, Fabienne?
Oh, it's a star just made out of neutrons, very dense and heavy. And yeah, it's the after a star like the sun collapsed, it becomes a neutron star. Is it the case for the sun?
It's a massive star, bigger than the sun. So when our star, a star like our sun evolves, it will become a white dwarf. But when a more massive star than our sun evolves, it will become a neutron star. And it's very small. The diameter is like 15 kilometers, or like Manhattan. So if you bring it to Earth to wait, you can bring it also next to Manhattan and compare the sizes. It's like Manhattan.
Okay. So most of you were right. It's just 15 kilometers. Next question. Which film does not feature the, how is it pronounced?
Arecibo
radio telescope, which just broke last week.
Yeah.
So sad.
Bad news.
Yeah.
Species, contact, or spectra?
I don't know two of those films.
So where it is not featured. Okay, yes.
Okay, just few of you were right. It's spectra, so most of you, but it's a difficult question. I haven't seen it.
I had to Google it.
I'm not a Bond fan, to be honest.
Yeah, it's a James Bond fan from the last James Bond.
Okay.
I believe that the spectra is the VLT, no, that appears. It's not a receiver.
Ah, okay. I don't remember that detail, but thank you.
I think.
Okay, next question. Which is not a characteristic or definition of a planet? A planet is in orbit around the sun, has nearly round or spherical shape, has cleared its orbit of smaller bodies, or its orbit is on the ecliptic plane. Which one is not a characteristic of a planet? You know, that's the reason why Pluto is no longer counted as a planet.
Another sad moment. I really like Pluto. It has a heart.
Yeah, it's true.
Yeah, but the heart tells us that Pluto is not angry, that it's not a planet anymore.
Okay.
Yeah. He moved on. He's like, whatever.
So a planet doesn't have to be in an orbit in the ecliptic plane. It's not necessary. But in our solar system, it's the case. Yeah, but all the other three are definitions of a planet, and Pluto hasn't cleared its orbit out of smaller bodies, and that's why Pluto is now a dwarf planet. Okay, next question. The conjunction of Jupiter and Saturn will happen on December 21st. The two planets will appear as one in the night sky. When is the next one? So they seem to be one planet. When is the next conjunction? In 20 years, in 15 years, in 10 years, or in 5 years? Maybe also interesting for astrology.
Of course, because, you know, it signifies something and it's very important date, okay? And it's also close to Christmas. It must mean something.
Actually, people since 400 years at least, people say that the Star of Bethlehem might have been a conjunction of Jupiter and Saturn. But actually, this is not true, of course, but this is the narrative, the publicly told story.
Yeah. I did a talk last year for Astronomy on Tap Bonn when we could go to pubs. So I gave these explanations. What can be the star? You know, the Christmas star. I will put the link on the chat so people can see it if they want.
I mean, yes, well, but the question is at all not put in the right way. I mean, who would have been able to do stargazing in this night? Jesus was too young and Mariah had to do other things. So who has seen
But the
that?
kings, the three kings.
The three kings.
No, that's a story that was needed some decades later when Jesus had died, and Matthew wanted to mission all the Jews and Romans around him. So he wanted to convince them. So he needed to remind those people, those living people, on things that they or their grandmother had seen some decades ago.
Interesting. Okay. Never thought about it.
Well, you're working in planetariums. You should think about those things.
Okay. Okay, what is the surface of a dwarf planet Pluto made of? So, nitrogen, iron, mercury, or carbon dioxide. So the surface of Pluto is solid. Okay. I think you're lost here.
That was too hard. That was a bit a tough one.
Yeah. So it's not iron, it's nitrogen. And it's so interesting because right at the moment you are breathing nitrogen through your lungs, but Pluto is so far away from the sun, it's so cold that nitrogen freezes.
So
Okay.
let's see the board of winners.
Yeah. Yes. I hope I can see it. Ooh. Oh no.
No, what happened?
Oh no.
So everyone wins.
Damn it. I couldn't see. Oh, here it is. Here it is.
Okay.
So, Suzanne, you are the winner. Congratulations.
That's the surprise, indeed.
80% right. DJ4279.
Okay, this is Evangelos, and he swears he hasn't looked at the answers.
Yeah, it's true. I think this time he didn't know.
Okay,
the
Evangelos.
answers. And Shaparo. Do you know him, Eleni?
No, but congratulations. Well done. And congratulations to everyone. And thank you very much for playing. I hope you enjoyed it. We had a lot of fun trying to find very hard questions for you this time. It worked. So I will also put some links about the conjunction of Jupiter and Saturn. So every night in the sky, you can see them now getting closer and closer and closer. So when it's not cloudy outside. And on the 21st of December, you will see them like almost like one. And if you don't see very well, like I do, because I'm old, you will see them like one for sure. Right. Thank you, Jim. That was really fun. Yes. Thank you. Glad you enjoyed it. Last but not least, this is the time to get your drinks.
Yeah.
So there is another, you have to click to the other link. Evangelos, if you may share this also with our live audience. So now you have to go again to the quiz link and put another code in, and you can participate in the last game of the night. Right. I will wait a bit because of the time delay.
I can start sharing my screen.
Yes, so please do.
We'll get a drink.
Okay.
Right. So Evangelos will share the link now. a minute so this happens. Right.
So the game is Never Have I Ever. And yeah. Okay, continue then.
Go for it.
Okay.
I'm doing the background.
Then it follows a sentence. For example, never have I ever, I don't know, been drinking alcohol in front of a camera. I'm doing this right now, so I have to drink.
Cheers.
So you drink if you have done it, but you don't have to drink if you've really never done it.
But if you want to drink, we're not gonna tell you not to drink. I mean, we don't control you. You know, you drink.
Yeah. So, and for our participants in the game, so if you have done it, click yes. If not, click no. Okay.
I think we're good to go. Evangelos has shared it, and people have signed in. Oh, yeah. Very nice.
9.
So NGC 4414 is a spiral active galactic nuclei, which is rare to have an active galaxy in a spiral. So the center of the galaxy is active. It releases a lot of energy in its environment. And usually these objects are found in elliptical galaxies, so they're more round. But this one is found in a spiral galaxy like Andromeda, for example. So that's a very nice galaxy. Right.
Have you heard of it before?
Probably, but don't remember the name.
It's just a number. Yeah.
Also, alcohol, kills brain cells. So there you go. Let's start then.
Okay, now we have 12 participants.
Yes, I think we're good to go.
Okay, good.
Yeah, good.
I start. So, never have I ever slept during a lecture.
Okay.
Really?
Cheers.
Especially during my own ones.
That's good.
No, really. There have been guided tours which I guided through museums, observatories, and I almost fell asleep because it was always the same to tell.
Oh, that is fantastic.
So really, I never did, because for me it's difficult to fall asleep, but that's it. Okay.
Congratulations, Aritra.
Most of you slept during a lecture. Okay.
I mean, this is how you become a professional, no?
Okay, next question. Not question, but never have I ever added a citation on my paper without reading that paper.
Oh my God. Okay, guys, drink, please. Don't let it be only me.
Well, I'm sorry, I don't drink.
I mean, I haven't published something, but yeah, maybe in my bachelor thesis.
It's a bad habit, but it happens more often.
It happens because some of your collaborators have cited that paper.
Well, no, normally I'm the one who reads the papers which are not read by my collaborators.
Okay, so most of you did this. It's actually not good. You shouldn't do this, but okay.
Right? Or you should include me as a co-author. Then we'll read it.
There is a list of papers where you can put.
Okay, never have I ever attended a telecon at 3 o'clock in the morning.
Oh, okay, cheers. I think I have one tonight.
I didn't.
Well, particularly if you have collaborators from both sides of the world, Japan and US.
I mean, it's good and bad. It's good that I can participate, but it's bad timing.
It's good that we can talk and everyone is happy. They talk at normal times for them. And you can alternate, So, Aritra is rocking this game.
So how do you say Gleichstand in English? Remi?
Balanced.
Again?
Balanced, maybe.
Okay, it's balanced.
It's a tie. It's a tie.
tie. Okay, thank you. So, next question. Never have I ever cheated at a test. I mean, it's very general. Of course, I cheated at a test.
I have never cheated at a test, ever.
Not at university.
Never. I have never cheated at a test.
Wow.
Nothing wrong with me.
And I was younger. I know I'm still very young, but even younger. Okay, most of you cheated at the test. Okay. Good. Next question. Never have I ever been to the office without doing any work.
Who made up these questions? Yes.
You know, you're having lunch and then a coffee break, and
Christmas
then it's
party.
almost 4, and it's, yeah.
Or you can discuss with your colleagues.
Yes, yes. Meetings, you know.
Exactly.
Yeah,
Okay.
talks, attend talks, yes.
I mean, does it count if first your boss comes, then the secretary comes, then your colleague comes, and everybody wants something, and you do, well, you are busy, but you don't do anything. Does that count?
Yes,
Yes.
it does. It does. Definitely, it does. This is exactly the issue where sometimes we have to deal. So it's a lot of time management. So you can do some work.
And I'm glad to see that most of you had the same situation or feel the same.
We feel like a unit now.
Yeah. Okay. Never have I ever complained about the job market and academia. Oh, I think we
Yes.
did this today.
We're like,
It's a
I don't
sport.
know, was it 20 minutes ago? Seriously.
Yes.
Oh, 3 of you didn't. Are you really happy with the job situation?
No.
No. You have to work very much, and you're not getting paid very well.
It's a lot of sacrifice, personal sacrifices also. Yeah.
I mean, if I'm paid at all, it would be sufficient.
Yeah.
I was in a situation where when I was not paid for 4 months in a row, and then after a year again for 4 months in a row during one of my postdocs, and that was a horrible, horrible time. So,
Yes, and you always do not know how to continue and what comes next and so on.
And sometimes it's just luck. I mean.
No, I was working. They just didn't pay.
Okay, without
yeah,
okay.
Yes, and for instance, if you are you finished your work of the PhD, and then you have to publish the book, but no one tells you how, no one pays you for all the typesetting in LaTeX of 800 pages of a book.
It's a lot of work. So what is never have I ever dropped a class project because I was not interested anymore? Oh, cheers.
Paper.
Paper, yes.
Okay. So it didn't happen to me, but
you know what you want.
Yeah. But I think most of you had the same situation.
But it's good to try, you know, and if you don't like something, you can always do something else.
Yep. So the next one, I think it's a complicated one. I have to explain it.
Oh, okay, yes.
It's okay. Never have I ever been sitting in a difficult lecture worrying about the exam, but I was still happy because I was thinking, at least I'm not the worst student. There's at least one person that's worse than me. Yeah, I always do that.
Okay. We have all done this. We have all done this. Let's not be, you know, let's be real.
But I think, it's too difficult. Then I think, there's still this one person. Yeah, he or she can not handle it. So it's not just a problem of mine.
Honestly, I do not really remember, but I want to drink something.
Okay. So I'm curious now.
Yes. Oh, right.
Yeah, so most of you had the same situation. It's a little bit mean, but I think it's okay.
Well,
Okay.
you know, we're only human.
Yeah. So that's it. Some commercials.
Oh, that's very nice and cozy.
Um,
Aritra, you are also very fast in replying, I think.
Yeah.
That's why, yes.
Mukul and
And guest, what is?
1526. I don't know if I should congratulate you.
Congratulations, because you drank almost at every question.
Okay. Thank you guys for participating. It was very nice.
I hope you enjoyed the games, and we offered you a bit of evening entertainment related also to astronomy and to culture in astronomy and academia, and so you learned a bit more about us and what it is to be a researcher in astrophysics. Thank you very much to Suzanne and Emilio for being here with us. To Evangelos in the live chat, of course. Thank you, Evangelos, for the support and chatting with our audience. Thank you to the audience, of course, for participating. I know everyone is busy and we are really zoomed out.
Yep.
So, yes, I mean, we only had like 5 hours of meetings before this on Zoom today, but I hope you enjoyed it, guys. Fabienne, again, thank you for setting up all the quiz.
Yeah, thank you.
Let us recommend the solar eclipse next week.
Please, yes, go ahead.
I have prepared something on that.
Awesome.
Well, there is a solar eclipse next Monday in South America. It's in Chile and Argentina, basically. And yeah, if you have the chance to watch a solar eclipse from the ocean. But yeah, unfortunately, it's not possible for people who not live there to go there because of the situation we all know. But on the other hand, there are always, not only during a pandemic, but even before, there had been opportunities to pursue the path of the sun. So for instance, there is the website timeanddate.com, and they are streaming solar eclipses. I followed the solar eclipse in, was it June or July this year, from Northeast Africa through South Asia, India, and so on, until Japan. And they always had, well, at certain points, they had cameras or webcams, telescope cameras or webcams, and they had partners to interview there. And I think they will do something like this for the eclipse next week too. So you can at least follow the occultation of our star, of the sun, by the moon at several places in Chile and Argentina through the live stream.
Suzanne, what is the link?
No, I already gave the link to Evangelos, and he will put it in our chat.
Yes, fantastic. Thank you.
Thank you, Susanne, for this nice suggestion.
Time and date. Yeah, also I know NASA websites sometimes has a live stream usually of eclipses, but you know, it's we're living in weird times, but you know, I've seen a lot of eclipses myself also live or, you know, online. No, unfortunately not in person. So hopefully one day when we can travel again.
It's absolutely recommended. I mean, currently during these days, I am at a conference which was supposed to take place in Argentina. And today, just before this Astronomy on Tap meeting, there was a presentation of a NASA person at this conference promoting these solar eclipse views, and he showed a view graph, which is really interesting because it was saying that normal events like supermoons, lunar eclipse, whatever you can imagine, conjunction of two planets, those typical astronomical events are somehow interesting. But compared to the, well, if you have the amount of interest and the events here, then all the events are here, and so a total solar eclipse, I mean, really 100%, not 99%, but 100% totality is somewhere out of the screen.
Amazing.
It's really, you should, something you should have done in your life.
Okay, next one, we arrange it.
Yes.
Yes, okay, and we do an astronomy on tap from there. And you can join us. Fantastic. I think we'll close it here so we don't occupy more of your evening. We will renew our date in a month. In the new year, with new experiences, new guests. So the next date, so mark it on your calendars, is the 12th, Tuesday, the 12th of January at 7 p.m. Central European time. And that's it. Thank you very much. And if you want to see this video again, you can see it tomorrow on YouTube.